Here's another example of a series parallel. This one's a little bit different than the one we were just looking at. If we come out of here, there's nothing in series with the whole circuit, but right here we get to a transition where voltage comes down here, voltage goes over here. As voltage travels down through this leg, these two resistors are in series with each other, and these two resistors are in series with each other, but these two and these two are in parallel with each other. So this is a series parallel. It's just a different type of series parallel. So to figure out, we need to figure out what our voltage value is. That's what we're trying to figure out. So to do that, I like to fill in my blanks, and so I don't know what my voltage is, but I do know what my amperage total is, which is 3 amps. And I do know what all my resistor values are. They're all 4 ohms of resistance. So I can add in all my resistance values. Now what I can do is I can apply any circuit laws that I may know or may be able to apply. And in this case, I'm going to have to simplify before I can do that, because I don't really have any circuit laws right off the top. So what I'm going to do is I'm going to simplify this circuit. So I'm going to redraw it. And I'm going to redraw it as a simple parallel circuit. And I'm going to draw my dotted line around it. And so this is going to be R1 and R2. This is going to be R3 and R4. Now to simplify these are just series resistors, so I just have to add them together. So this is 8 ohms, and this is 8 ohms, because I can apply series laws to these two. Now what I've done is I've just drawn a parallel circuit. So now all I have to do is simplify the parallel circuit. So if I want to redraw that again, and draw my dotted line. Now this is R1, R2, R3, and R4. And to figure out what my resistance value is, I can use the same value method. So I've got 2 resistors here. Their value is 8 divided by the number of resistors, which is 2, and that gives me 4. So 4 ohms of resistance. So that's going to be my total circuit resistance right there. So I can actually go ahead and write that in over here on this side. So my resistance total is going to be 4 ohms of resistance. Now what I can do is figure out what my voltage total is, and that's what we're looking for right now, because all I have to do is my Ohm's law here, which is 4 times 3 is 12. So that's 12 volts. So that's my answer that I was looking for here. Let's double check and make sure that we're doing this right. Okay. Now the way you would double check that is see if you can fill in the rest of these blanks. So the way I would fill in the rest of these blanks is I've got to figure out how much voltage is going to go down each one of these parallel legs. Now there's a couple of ways you can do this. Since we know our voltage is 12, it's going to be split, our voltage is going to be the same through all the parallel legs. So I'm going to have, let me do it in a different color. So I'm going to have 12 volts here, and I'm going to have 12 volts here. Don't jump to conclusions and write 12 all the way down, because you remember these two are in series and these two are in series. They're going to share the voltage. They're not going to be, so in other words, volt 1 and 2 are in series and 3 and 4 are in series. So this is a series and series, and then these two are in parallel, okay, with each other. So if I think about it that way, now coming down the circuit line, I can do this in my head because these are both the same value, and I've got 12 volts. So they're going to use the same amount of voltage each. So 12 divided by 2, that's going to be 6 volts. So these are going to be 6 volts because they're all the same value and they're all 4. So 6 volts. So now I can finish calculating over here and do a little bit more math to see if I'm doing this correct. So 4 divided by 6, I believe, is 1.5, I want to say. So, sorry, 6 divided by 4 is 1.5. So when they're all the same value like this, it makes it a little bit easier. So now I can go back and double check myself. So remember, these two are in series, so 1.5, 1.5 is 3, okay? And so that's going to be 3 amps here, and then 3 amps here, okay? So that adds up. And then our resistance total, we can add that up as well. We can go, because these two are in series, right? So that's over here. So 4 ohms and 4 ohms, that's 8 ohms. So this is going to be 8 with these two, and this is going to be 8 with these two. And if we do our reciprocal sum method, which is 8 divided by 2, that equals 4 ohms of resistance. So hopefully you followed along with that. You have to treat, these two are in series with each other, so I have to apply series circuit laws. These two are in series with each other, so I have to apply series laws. But these 4 are in parallel with each other, so I have to apply parallel laws. So that's how you would do this circuit.